All right, wanted to help you guys out with a WebAssign question. So this is from our one-dimensional motion WebAssign question 10. It's the one with the bus slowing down and coming to a stop. So let me read it real quick. A bus slows down uniformly from 21 meters per second to 0 meters per second in 24 seconds. How far does it travel before stopping? So like we said, in order to figure out which of the big three equations to use, we want to do a KU chart. This one's pretty straightforward. When I hear slows down, I think of the velocity changing, and these units confirm that. So it's going from 21 meters per second, that would be the initial velocity, to 0 meters per second, which is the final. If you weren't sure which one was initial and final, it also asks how far does it travel before stopping. So that would lead me to believe that the final velocity is 0. So initial is 21 meters per second. Final is 0. And it says right after that, this happens in 24 seconds. So that, of course, is a measurement of time. So the givens were pretty straightforward in this. Be mindful yours are probably different. All right, WebAssign changes them up. And once I have three knowns, I'm probably good to figure out what does it want me to solve for. Well, it asks how far. So when I see how far, it makes me think of displacement. All right. So KU charts are essential. Keep doing them. You'll get better and better as you practice these. But then the idea is I want to find the equation that has all four of these variables in it. The issue, long story short, is none of them do though. All right, some of you might be thinking, well, I would like to use this to solve for displacement, but I don't know the acceleration. Well, let's think back to the whole big idea that our labs taught us. Acceleration is basically saying the velocity changes in some amount of time. So what's interesting is I'm actually given both velocities here, all right, so I can figure out the change, and I also know how much time it's taking for this to occur. So this is everything I need to actually define the acceleration, which is actually this equation. This was our slope, or our acceleration equation, basically defined, rearranged. So what if I actually take this equation, and of course I would rearrange it. All right, so move variables around. You actually subtract VI first, which would then give you VF minus VI. And then to get acceleration by itself, you would divide by time. And voila, that kind of looks like how it started in the slope formula, right? This could actually let us solve for the acceleration, plugging in my knowns here. If I then know the acceleration, so I could add that to the knowns once I solve it out, I could then actually use this equation. All right, I know the initial velocity and the time it's taking, and now I've solved for the acceleration with a separate equation. All right, so I can plug that in there. You can clearly see why I chose this problem because it was a little tricky. We actually had to use two equations to get to where we wanted to, but think of the big ideas, all right, especially this one. If I know the change in velocity and the time it's taking, I should be able to solve for the acceleration based on the definition, okay? I'm not going to solve it out because your numbers will differ, but I hope this helps out. Keep practicing. The more you do, the more confident you'll become. Hope this helps, guys. Good luck.